gentleman labeled it air. He says that he is something you learned in 7th grade.
Respiration.
Is respiration. Sure. It's also trying to put into practice something that he thought. He thought air exists. Something might not be all of the proof that you need to prove that air exists, but it is a proof. It is something that you can point somebody to and say, try it. See if you... He actually tried to figure out, how can I prove, how can I demonstrate, how can I see if this thing really exists? Or is it all just a dream? Is it all just a figment of my imagination? He demonstrated what I hope all of you have, an ounce of curiosity. Not to prove it with great elaborate experiments, but to prove it with very simple, common sense things that you can do. By thinking about, what did I just see? What happened? What is it? Gas. What is gas? Yes, sir.
Matter.
Gas is matter. Liquid is matter. Gas is matter. Over mind. You've heard that. Mind over matter, right? And if you don't mind, it don't matter. Okay? And if it matters, you should mind. Nonsensical statements, weren't they? But there's a ring of reality to it. What's your... Very much like a bird does. There's actually been human-powered flight. Somebody using basically a bicycle chain to turn a propeller to move an airplane through the air. Just using his own power of his body and her body, because it was a man-woman team that did it. Man-powered flight. What your mind can conceive, maybe not this year, maybe not next year, maybe not for 1,000 years, someday, someone is going to try to put into reality. People conceived flight thousands of years ago. People tried it, and they plunged to their death as a Greek mythology. Okay? Parachute. If somebody told you they're going to go up to a tall building and jump off the tall building with a bed sheet on their back, you would say, you're crazy. What's a parachute? Years ago, little toy parachutes, you tie little handkerchiefs together with string and put a little weight on it, you throw it up in the air and it opens and the weight drifts down. People realized that there was something in the atmosphere, they didn't call it an atmosphere, there was something around them that they couldn't see, but they could taste. Salt. I mean, somebody got a salt shaker and you stick out your tongue and they salt it for you? What are you tasting?
Salt water. Salt air.
Salt in the air, sure. Salt in the air. But wait a minute. Oh, you just got to get another piece of salt. Can you see it? Maybe your mom and dad doesn't cook it. You smell things being carried in the air. Why doesn't the air escape into space? Yes, sir.
It has weight.
It has weight. Yes, sir.
Because the ozone layer.
The ozone layer keeps it in place. Okay. Yeah, that's what you were saying, because the zone. Yes, sir. Gravity. Valve, it uses this valve to blow it up. That's good enough. We don't mind if the world is a little flat, do we? Does it have to be perfectly round? We'll just make it a little flat. So it's a little flat on the top and the bottom and bulges a little bit in the middle. Which is up and down? This is up? You sure? This is not up. This is not up.
It's on. It don't matter.
Congratulations, it don't matter. The world is in space, isn't it? I mean, where are we? We're right over here in dear old Newport News, Virginia. Right? Or in Hampton. We cross the line. Tidewater's in Hampton.
Accent doesn't do it in seconds. So we're going to be working with degrees and then minutes. And the way you write that is, you probably know how to write degrees. We've already written 90 degrees. 45 degrees, that has a little circle after it. And let's say it was 3 minutes. 3 minutes. You put a little slash after that to indicate it's minutes. Okay, 45 degrees and 3 minutes. It's set it so the 0 on the top scale and the 0 on the bottom scale meet. Okay? If our sextant looked like this one right here in the picture, then we have 30 degrees, because the 0 lines up with the 30. But notice these little bottom ones. We're looking for how many minutes now? 4 minutes. That's because the second line they're saying here, and it goes by twos, the second line meets exactly. So you can see it, all these don't meet exactly. And who didn't get a lab yet? All right? To read the angle of elevation, read the degrees by noting where 0 on the vernier scale points. Okay? Put your 0 on the vernier scale right on that 30.
I still don't get it.
Move your vernier scale around until the 0 lines up with the 30. Everybody got that? Okay, if it's between 30 and 31, then those two lines aren't going to add up directly. What you're going to have is 30 degrees and some amount of minutes.
2?
See if you can look through here and see which two lines on the bottom match exactly up with the top. Just a little bit. Everybody's got something different. Okay, if you move it just a tad between 30 and 31, see how that's between two numbers? 30 and 31? Now you gotta see which one of these lines up on that.
You're at 21.
4. So first we would say, okay, it's 43 degrees and how many minutes? Then you gotta look down at the bottom scale and see which one lines up exactly. The bottom. You've got to say it's 29 degrees plus 29 is where that 0 is. That line right there represents 29. See if it's 20, 21, 22, count all the way down to 29. It's 29 plus something. We don't know what it's plus.
How many minutes?
Yeah, how many minutes? Well, that's when you got to look at this bottom scale. Which one of these lines at the bottom lines up exactly? Can you find any two lines that line up exactly?
I can.
From the top to the bottom?
Isn't it?
Well, see if you can see which one lines up the best exactly. Look on here. Which one lines up the best?
I think we're all
Okay. All right. Well, 20. It goes by 2, so if that's 22, the next one will be 24. You looking? That'll be 24. So you add 29 degrees and 24 minutes. You see how that works?
29.
First, you got to figure out your degrees. And you probably will find that when you look through the mirror, it's not going to be even like that. What your job is to make it even. The mirrors need to be even with. You got it. Let me see.
can see through.
Okay, see those two pictures up there? First you'll see the first picture, and then you want to adjust it,
Might be.
it's like the second picture.
Can't you see through?
See how the box goes straight from here?
Look for you. Look at the mirror. That's what I've been doing. And all I see is those blue signs.
So that you're almost eye level with your horizon. Yeah. Okay, what did you focus on?
No, you can't.
Put
See,
your
look.
hand right here. Reflection.
Let me see where you're sitting.
Put your hand right here like this.
I can't tell. You gotta be at the same exact position.
You're gonna see the same thing that you see from how you
Could you tell me how to look?
Stay on zero the whole time?
Yeah.
No, it just stays on 0 while you're finding your horizon. After you find your horizon, you're gonna change it. Okay, so you have found your horizon. When you find your horizon, it's got to be on 0, 0. Okay, now let's look back at our directions. You now know how to find your horizon. If you chose a high horizon, you might want to choose a lower one. And just choose something and see what elevation it is. I'm going to come around and check that. First, just check the picture, and then you want to learn how to read your scale. You can use that same horizon you just found. Then you're going to pick something else that where the ceiling meets the wall is a good thing to measure. That's a straight line. Straight lines are a little bit easier than...
Would stay on top. Okay. The red one would stay on top. What do you think? The red one would stay on top. Okay? The red one would be on top. On top. Okay. A couple of people said the red is on top. A couple of people actually said the yellow was on top. And one person at least just pour the yellow into the red. Hold it up. Hold it up. Okay. Okay, what have we got? You're talking about instant bases now. Both of these happen to be bases. How about looking at the scientific instrument and describing and telling me exactly what it consists of? Okay. Whatever you see. 1.0 is what he sees. All right? Once you take it out of the red liquid, and remember everybody, he said it was at 1.0. So let's see if it goes down that far in the other liquid. Okay. Whatever you see.
Just measure between them. Yeah, there you go.
Measure from the back. No? That's it.
Did you find it? Where they were sat here.
Where's the next one?
That brown sign? Yeah. I mean, that's the last two.
That's the last one?
Huh? Got it. Five. Oh.
This 3 is 27, plus the $2 that the clerk got, and I say, what happened to the other dollar? It what? For taxes? No, no taxes involved in this.
Cash first.
What do you think? You think one paid $1 less? Who? They each put up $10, they each put $1 back in their pocket. Who got, you know, they each paid $9. Do you agree with that? Or do you think someone paid less than 9? Why? Why do you think that? Each person put up $10 and each person got $1 back in their pocket. Okay, you're saying there's something there, but you can't figure out what it is. Is that what you're saying now? Okay, what do you say?
I think there's like 2 different ways to do it. Because if you have three tens and then you take 5 away, you get 25 and then it's even. But if you do it like you were doing it in minus 1 feet,
$3, that would be 28. And so the clerk got $2, so it's good.
That's right. Now, here's what Alex has said. Now, I'm going to change his words a little bit. There is no missing dollar. There is no missing dollar. The way he explained it, he took the numbers and he did his own adding. He added. He didn't let me add for him. The way I was adding, I was coming up with 29. The lesson here is you have to, and this is it's got those 3 things. The only available boat is a very small, can't carry but 1 possession and the traveler at one time. So when the traveler gets into the boat, he can only put 1 of the 3 possessions in the boat with him at a time. Now, unfortunately, if you leave certain elements here alone, such as if you leave the goat with the cabbage, the goat will eat the cabbage. The wolf, if left alone, will eat the goat. Now, the problem that you've got to figure out is, how can the traveler transport his belongings to the other side of the river, keeping his vegetables and the animals intact. In other words, he doesn't want to leave them alone, those bad combinations. He doesn't want to leave those bad combinations alone. Okay, you see it in writing? No, he doesn't have it written down. I need to see it in writing. Okay, you're saying you take the goat over. Okay, the goat is over here. Then he's going to come back, he'll leave the goat over there. He's over first.
Then the man be on one side, he's gonna be.
When he takes the wolf over, what's happening to the cabbage?
Okay,
The goats.
cabbage first.
Okay, if he takes the cabbage first, then the wolf will eat the goat.
No, I said cabbage.
Okay, if you take the cabbage first, he's got to leave the wolf and goat by themselves, and the wolf will eat the goat if he leaves them by themselves.
And then take the cabbage and go. Yeah, wolf, cabbage, goat. Oh,
Think about it.
Take the wolf and the cat. Well, what if the man don't get in the boat and the wolf?
No, no.
well, you have the cheese, right?
Good, good. Okay, good solution.
Okay.
All of the groups figured it out. Now, no, we merged those two groups. Okay, next problem. Next problem. This one.
I think I know.
This is 3. Later.
That's okay. No, they're not the same. One sec. Equals whatever it is, 6 divided by 2 times 1.
Leave off to it.
This is her, Pam.
Who's behind her chat?
Lower.
Do the first one?
Oh, sorry.
Yeah, the first one. Just say the little one.
Yeah.
-6y.
Right, -6y. You could have written it y times -6, but this is the preferred way. That's not wrong. But number 9, subtract y from 6. Manual. Do what now? Yes, 6 minus y.
Y minus 6. I mean 6
6 less 15, you have y over -6. Number 17. Just the oral exercise. Now you have the written work to do.
Understand it? So what does that mean? What does that mean when it says he started in the middle? What does this represent? The middle rung of the ladder. Okay.
Yeah, that sounds good.
Okay. This ladder only, it's only one ladder we're talking about now. You say 7. You say 7. You say 7. You say 9. You all need to. top. If this is the middle, same number of buttons. Okay.
So it's 7. 1, 2, 3, 4, 5, 7.
Yeah, but what about those steps or rungs that are down below him from where he started? Yes, you do know. There's enough information based on what she just told me. There's enough information for you to know.
There's 9.
That's the correct answer, but show me how that's true.
Because 1, 2, 3, 4, 5, 6, and then he went down. 1, 2,
No, he didn't go down at first.
he went up. Okay, so he went 1, 2, 3, and then he went 1, 2, 3, 4, 5, and then he went 1, 2, 3, 4, 5, 6. And he made it.
That's correct.
Benevolence is a big word for good. For good life. Benevolent means good. Malevolent means bad. Mal means bad. Benevolent means good. You're going to be influenced by a benevolent manipulator. Y'all know what a manipulator is, right? Yeah. Okay, I'm a benevolent manipulator.
They do make people look crazy.
They
do.
They act like they know what you're talking about. Psychologists are some of the most misunderstood professionals in the world. And part of the reason why it's misunderstood, psychologist does, which is, if the psychologist is a good one, benevolent, manipulate unhealthiness to a state of healthiness. And they do it in a way whereby 7, 2, 7, 5, 4, 6, 0, 1, 3, 9, 4, 3, 9. Anybody in the classroom who thinks they can repeat those numbers back to me exactly? Okay.
7, 2, 7.
Good try. Good try. Yes.
Written down.
No, that's not going to work. Okay. You can do somewhere between 5 and 7. Think about it for a second. And I want to see a show of hands. How many kids think they can remember at least 5? How many think they can remember at least 6? Accurate. 1, 2, 3, 4. How many think they can remember 10? Put your hands down. I got one who thinks he can remember 10. Let's try.
Rate of roller coasters. Station. I'm a leader in canoes. Yeah, right. I'm ready to do what I can.
All right. Somebody else. Let's go. Right here. Come on.
Jamie, I am different and I am 15.
All right. Okay. It's good to be different. What if all of us were the same? It would be a dull world, right? Okay, right here.
I'm John Petty and I'm 15 now.
All right, so next bit. Right here.
I am Eddie Jones. I am a great drawer. I'm interested in the cartoon business, and I'm brilliant when it comes to hiding stuff.
Okay. Who hasn't been? Tiffany. Tutu. Oh, who's Tiffany?
That's Tiffany.
Oh, okay. I have a sister named Tiffany. Okay.
I'm energetic.
Difference between listening and hearing. Somebody. Tutu, you said you like to talk. Let's talk. Listening. What is listening? Perceiving sound. That's hearing. There's a difference between listening and just hearing. A lot of things we hear, okay, sounds. Did y'all hear that? You did? Did everybody hear that?
Yeah.
Okay, that's just a sound. You know, there are cars going by, trains, for improving listening skills. Number 1. I know you can read, but I'm going to read it anyway, okay? Say aloud to yourself each morning, I must listen today so that your mind will snap to attention. Now, I don't know how many of you guys get up and say that, but make it a habit.
this how we erase the whole street? Is it essential here?
It's like an artwork. If you do something to it and you don't want anything to happen to it, you can go in and save what you just did. So go and save. And you got your house, TCX. You like this better than the old one? Okay. That's our house.
That's working.
Okay. That means this will save with this house. Okay? So you go down and say, okay. It says, do you want to write it right here? It's Jake, right?
Right.
Slide down to the name Jake, pick it up, click, and say, okay.
That's what we always see.
Okay.
Really see.
Good.
I don't know what.
Okay, now I'm going to give you an assignment because we're going to do some things, finish today and then the next time, and put some pieces together by saying in different places. Little did a piece of fruit is what they started with. Like some did an apple and some a pear and some a peach. And then they're working on like a prairie scene or a skyscape, and they're going to bring the apple into that or the pear into that. So what I want you to do is pick something very small to work on. Whether it's an apple or a pear, probably a couple inches big on your string. Or if you wanted to do, if you don't like that idea, then you come up with something. Whether it's a little monster or I don't care. Something small, okay? Don't use. I want you to make something. This thing is all the fruit. I want you to stick what you want to. Okay? Now, is this your option? You're starting to, you're kind of big. Can you make it look, because we're going to resize it. We're going to stretch it forward. All sorts of good stuff, but it's already too big. We can't do it. So make it a... All right, take your, go down and get white.
Right.
White with your left foot.
Why do you use like that?
No, every pixel has to be closed up. It's
That's it.
Work right in there.
I'm trying to get my color changed, but it won't change.
What color do you want to change to?
I'm trying to get this color.
Your left mouse button, remember, for your drawing color. That's right.
I was pushing the middle. See, it's drawing orange.
Just do a piece of fruit then. You do a nice and it works well.
Now this is where the sound is going to get in. Watch that plus. One is circle down. Plus going to be left down. Now stretch it.
You should, but I make a mistake and forget that I changed the color to stand on the highlight, and I end up messing it up. Yeah, but I don't like that red color.
Here we go.
Sorry.
Great. What is it? Yeah, I did change. I'm drawing, I ain't done, man. I got a cherry. That's something good.
What did you just say?
You got a glare on.
I'm scared to do something too.
I'll take a picture of it in a second.
She made grapes. I love you.
Look just like human beings. But their fingerprints are all alike. Don? Did you hear what I just said? Something about genetics, Mr. Gonzalez? Larry! What about you?
460-139.
Time.
439.
All right, let's give her a hand. Yeah, okay. Now, part of what I'm going to say to you folks is that there may be lots of times when things are going to seem like they're impossible. There's going to be lots of times when there are things that you can look at and say, man, I can climb it. And there may be things that you can learn to do it so that you can succeed. And certainly, just trying to remember those 13 digits may have been something that was something you couldn't do ordinarily. But what you all learned, what I taught you all, was what's called a chunking device. A chunking device is a way of splitting up or dividing information into meaningful parts so that it can be understood. And the chunking device you all learned had to do with the Boeing airplane, and the last chunk had to do with time. So what you did was you took a difficult task and you found a way to master the task by learning a technique called chunking. Okay? The point I'm making: explain, predict, and control. And I'm going to get you all to now tell me how. Yes. Exactly. Testing. When you test people, you get a sample of their behavior. You test people or evaluate. Test. How then information that addresses behavioral, how people behave. Okay? Your hand was up.
System.
Yeah, another way is look at the systems model. And these
We'll help you. Would someone read the problem, please? Yes, on example problem, right at the top, on page number 5. Sorry? Where it says problem.
I know, it's ordered and I'm gonna let you read.
Oh, I'm sorry, that's tricky. When it says feeding bar count 60 milligrams, PO means find out. If you want to write that down, you see that all the time when doctors are ordering.
What does it mean?
Whenever you see the word, that big PO, and the PO, it means take it by mouth, that it's a pill that you can swallow. BID means twice a day. You don't have to learn that now, but again, you will see things like that. It means that 30x equals 60. X equals 2. 2 tablets. Is that clear to everybody? Does anyone have any? These are quite uncomplicated. Some of them can get real tricky when you go on with this. Okay, like this next one. Would someone please read the problem? This is at the bottom of page 5. It's another name for that drug when you're seeing it like that. Okay.
Score tablets, 0.35 milligrams.
Okay.
Will do?
Do you want to try this problem?
No.
Oh. Okay. Do you know how?
0.5 milligrams. Times tablets. X tablets. E.
Okay. Okay. First. Okay.
0.35 x 0.5
Yep.
times x equals 0.
Tablets. Scored means when you see the word scored, you can break it in half. You can just cut them yourself. But what's ordered is 1/120th grain. So we're not, if you notice, okay, go to your conversions. How do I explain this? Let me see. We need, okay, what do you think, okay, we have to convert the grains into milligrams. Does anyone know how we would do that? By looking at this, what we would start to do. Different than what's available. You have to make both of these things be this, like milligrams. We want to work right now in milligrams instead of in grains. Have you worked with things like that where you have to, let's see. We want to change this 1/120 grain into milligrams. And the way to do it is, we know that 1 grain is to 60 milligrams. So we want to know how much 1/120 is to how many? 0.5 what? Milligrams. That's what we're looking for. Now where you have that problem, see where the sign says ordered? Cross out that 120 grain and put in 0.5 milligrams. Because now the problem is easier to work with because we're working in milligrams. Okay? That problem. Now that we're working with that, we can finish the problem. We can say, 0.25 milligrams is to 1 tablet, and 0.5 milligrams is to X tablet. 0.5 X equals 0.5. Do a conversion to get what you want. I'm going to go back to a little bit easier ones. Let me see. Would you all turn to page 7?
Listen to the question. If you knew that, what's today, Friday? Say we were in school, and and this is Friday, we in Friday, or whatever school you went to. And we have exam in, say, English on Thursday, next week. Okay, when do you start studying?
Tonight. 9 to 4. Tonight.
When do you start studying?
Tonight.
If you knew that much in advance, then why don't you start studying it that much in advance? And if you study a little bit every day, then you don't have to wait until Wednesday night to try to cram all that stuff in your brain and all let it leak out of your ears, because that's what happens. Okay, I hope that's not your philosophy that you studied the night before, because for years I can almost know what your grades look like. Okay?
Can we have
Huh?
Can we have?
Yeah, this is for you. I was up all night to put this together.
We were doing all the evaluation on that class we just took. We are. What? That class we were doing all night. Huh? What? I don't care about this. I don't do evaluation. I don't like that class. That class is long and hard and cold. Evaluation.
You want me to support that?
I was copy at my school because I want to be able to work next year and enjoy life. Okay?
Okay.
Let me go with some other tips. Now just listen. This does not have to do with what you have on your desk. Just lay that down. I want you to listen. But most of it you can still use. I don't care if it's middle school or high school. Tip number 1, attend all classes. And you know it's very important when I say attend all classes that you come to school every day. Because when you're not there, you're missing something, right? Hello? And unless you're on your deathbed and you're so sick that you can't get up, then you should be in school every day, right? Right? So attend your classes or attend school every day. Okay, every day that we have school, you should be in there. Listen carefully to information discussed in class and participate in class discussion. I've been saying it ever since I've been here. So evidently, it must be the truth. Right, Luke? Okay. Ask questions about any information which may seem unclear to you. You will find it useful to ask your teacher for help on classwork or homework assignments if needed. Be sure to bring home from school each day books and other materials you need to complete your assignments. How can you do your homework and your assignments when you left your books in your locker? Right? Kind of impossible, isn't it? Okay. Use the same time each day for study and homework. Okay? When you get home, if you normally study, say at 5 o'clock or 6 o'clock.
I told you, I'm just having a terrible time. And you go over to the little porthole, and you take your cap off, and you put up in there in the porthole, and you shake it up a little bit, and all this mixes up, and it goes into the arm. But you've got to know how much medication to put in this syringe to put in there. Give this patient too much Valium, you're going to kill them. Give them too little, won't do any good. So you've got to learn your math to know how much medication to put in there. So these are some ways that you use IVs. And when you get into the hospital, they have machines in there. Here's all this stuff. Yeah, this is one of them. This is a piggyback here. But as a nurse, you have to learn how to use all these things. So you've got to know your math, and you learn. I mean, that's what you will learn in your nursing school. So IV medications are another type of math. Y'all want to ask me any questions about anything? Think you might want to be a nurse someday?
I had to send him to Pennsylvania.
I don't know.
He was
It's
a
all
victim.
old
He had
stuff.
no weapon,
There's no
and
telling
then
us to do. These things are 5 or 6
barred
years
him
old.
from the
I think.
base. And then barred feelings people from the base.
But we don't actually ever put these in with people. We just practice techniques.
Was you at the farm?
That's what, this is just a practice.
We got for sure.
In a real hospital, you would have sterile, clean, up-to-date equipment.
He walked up to me and
Now, if you want to go back a minute, Meg's going to show you how to calculate a few IV drops, and then I will answer any questions, or if there's anything y'all want to know about. Anything I can answer for you? Any questions about nursing you want to know? There's lots of young people in nursing.
1 minute for treatment.
Leave it alone,
You know,
it's
like, like check the records and stuff.
Check your records. Some of these might have real needles on them, so be careful.
Go ahead.
Okay, like, as funny as I saw it is, she got the medication, she had it out. She pushed it out, and then she put the needle in, and then she pushed it back in, and then she just pushed it back up and liquid came in. Like, you have to do it 3 times, in, out, in.
She might not have, I'm trying to think of them. Let me think, if I was doing it.
Like push hard, and some of them are real loose.
I want to show a couple of them. I had to do that when I was in hospital.
Y'all take your seats and we'll wind this up.
Excuse me.
We get to go to the bowler.
Okay.
Yeah.
Okay. Now what I'm going to do for openers is I'm going to make some liquid nitrogen tea. And I'm going to put it in here. Yeah, this is like iced tea. So you can see I'm pouring some liquid Oh! I better make a little bit more here.
There you go. It beats up on the floor.
Okay, see, I put it on something good and hot, which is just this ice here. So, you know, this is like my stove. Yeah, the neat thing about liquid nitrogen is you don't need an electric stove to boil it. You just bring in some ice. So, and I don't know it. Okay, that's a nice full cup there.
How many of you know what's in the air that you're breathing right now?
Nitrogen.
What else?
Oxygen.
Good. Do you know about how much of each?
7821.
Great.
Okay, let's see what happens to this. Well,
Hey!
That's kind of cold.
feel it. Okay? Okay.
They do that too.
Now I
Do
think-
a banana. Do a banana.
You guys got those. Okay.
Wow.
He got the whole house.
Let me show you a little bit about temperature before we go on, because we're going to talk about superconductivity.
And you can see right now it's displaying room temperature. It's kind of warm in here, 23.7. What's that in?
What units would that be in?
Celsius, okay?
Celsius, good.
And you can see if I put my fingers on this, that it'll go up, of course. And if I wanted to measure my own temperature here. I'm cold this morning, I have to go up to 37. Okay, but let's just demonstrate that ice water.
What would you expect to happen when he
What would
puts
you
it in
expect
ice?
ice water to be in Celsius?
What value in
What
Celsius?
value? Anybody know?
Very low.
Very low. Anybody got a number?
What? Yeah, I heard it.
Zero.
Zero, right.
Right. That's the starting point of the Celsius scale, because the freezing point of water is a very convenient point.
Okay, we're down to 2 point something, and I don't have crushed ice, so this is probably not going to get right exactly to zero, but it's going to be close if we let it equilibrate and sort of shake it. And
And another thing you should realize is you can't trust any thermometer to perfection.
Right.
So this could be off slightly, but it's more likely that it isn't quite cold yet.
Yeah.
It's a mixture of ice and water.
Okay, so now what we're going to do is we're going to take this.
It's all negative now. And it shot down to 197 just like that. So that's
You see it?
how cold that is.
So it is really cold in there. So working with this stuff, and we soldered 2 wires in on each side, so that we've interrupted it. When I turn on the flashlight, nothing happens. Okay, unless I connect the wires. And if I connect the wires, of course, it's a perfectly good flashlight. But what I want to show you is that if we put a resistor in there, well, tell me, what do you think is going to happen?
What do you think will happen to the flow of electrons?
I've got it's all hooked up, it's turned on, and you see nothing, right? And if I crank the resistor down, it glows dimly at first, and then as I crank it towards 0 ohms, it goes bright again. So as I can dim it or brighten it by doing that. And this is you wouldn't use this in a TV or anything. If you wanted to use resistors that might be in some of your high-tech electronic stuff, they'd look more like this. I put 4 of them together here, but I can do the same thing with them. Just hold my hand on one side here, and you can see that one is pretty bright, but if I get down to this one, it's getting pretty dim, and in between I've got some values in between. I can use 2 resistors in series, and it's so dim you can barely see it. Okay, so this is a standard resistor. Now, I've got another flashlight that's, let's see. I just turned it on. Nothing
Have
happened.
somebody feel the coil.
Yeah, no, the coil is this part right down.
It's a little thing that's got
Very thin wire, if you look at it. Let me
Feel
take
it?
around.
Yeah.
Yeah.
Coil's hot. Why is the coil hot?
Because of electricity.
Yeah, the electrons are interacting with the impurities in the metal and they're forming.
It's pretty hot.
Actually,
Have resistance? We cooled off the coil, and the resistance got much lower. The resistance, remember on there when we lowered the resistance, the light got brighter? So, and if I take it out and heat it with my fingers now, what happens to the light? So the hotter the coil is, the more resistance there is in the coil. When they cool it back off again, it comes on again. So we get less resistance. Okay.
All right.
Don't laugh at it. Cute. No, wait. I'm getting ready to change the light.
That is not a tomato. I'm gonna make it. Like an apple?
No, you can't erase all that. You're gonna erase the colors. I'm gonna erase that.
So, what happened?
There you go. There you go, that's a shame. No, right, yes.
The kids are caught up.
Right.
The arrow tells me.
Oh, I see now. Oh, I see what I'm doing. Shifting, yes, in my own. Hey, I'm messing up. I didn't want that.
She laughs. What happened to your cherry?
It went away. No, I made my circle in the wrong place and then you can make it in the wrong place.
Well, she's, you got a little point inside.
I'll show you what it looks good. And then it looks breaking.
Yeah, I messed up.
Take go and get your white, bring a little bit of highlighter.
I think it looks good.
Or you can go.
You all notice the little, when you spill a little nitrogen on the table, what happens to it? It balls up, right? Have you ever put water in a hot frying pan? You know what happens? Right? Liquid. Okay. Now we're okay,
With signs, you should be able to do that. What we want you to do is drop them in simultaneously and have somebody time, start a stopwatch when you drop them so that you know how long it takes each one to stop boiling. Now there is something special that you'll see